Good morning everyone. I am Dr. Lavanya, Assistant Professor of Physics, A.D.M. College for Women, Nagapattinam. We will discuss about viscosity. Viscosity is the characteristics of flow of fluids. Okay, it is something related to thickness. We have seen water, we have seen honey. Some amount of water throw on the ground, the water molecules goes a long distance. At the same time, you cup of honey throw on the ground, the honey molecules does not move that state because the honey molecules move forward, but the resistance is pushed back to the molecules. So from this process we can conclude the honey is highly viscous liquids. Okay, so viscosity, if I am taking I am taking the stance with the fixed plane. Fixed plane, water, we know that water is the water fluid in it, different layers. Different layers, that is consists of layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, like this. Okay, so when this particles, no force applied on this water molecules, the particles in the same position, that is the position of the particles at the t is equal to 0 seconds. That means they not apply any force on that fluid particles. So this is the position of the particles at t is equal to 0 seconds. After some time, if I am applied the force on that fluid particles, the particles moves in different direction. That is the particles in the deformation positions. So different with different velocities. That is up to t is equal to t seconds. T is equal to t seconds. Is it clear? You have to take as a water fluids. You have to no force applied on that fluids. At the time t is equal to 0 seconds, the particles, all the position of the particles is the same conditions. After some time, I applied the some amount of force applied on that fluid. What happened? The position of the particle is deformation with different velocities. At that time, up to t is equal to t seconds. Okay, these are the position of the particles. Suppose we have compare the position of these particles. At the rest positions, all the particles are in same direction. But I am applying a shearing stress on that fluid particles. The particles moves in some deformation position. The particles move in some different velocity with a different deformation position. Okay, we all of you know that the water molecules, fluid in different layers, layer 1, layer 2, like this already I told. Here the layer, this is the layer 1, this is the layer 2. Now I applied the force on that layer 1. The layer 1 moving the layer particles of the layer 1 goes to the deformation position. At that point, the layer 1 exhibits the resistance. This is the layer 1, layer 2, layer 3, layer 4, like this. The layer 1 exhibits the resistance to the layer 2. Okay, the layer 2 exhibits the resistance to the layer 3. The layer 3 exhibits the resistance to the layer 4, like this. Due to this, the resistance offered to these fluid particles. Okay, is it clear? So the resistance. So from this process, we conclude that the resistance offered the layers of the fluid particles is besides the layer 1. So suppose the resistance of the resistance offered to the layer 2 besides to layer 1. the resistance offered the layer 3 besides the layer 2. So the resistance offered the fluid particles of the layer 4 besides the top of the layer. Okay, the resistance offered the fluid particles of the layer 5 besides the top of the layer. So that's why the velocity profile we compare. That's why the velocity profile. Suppose the velocity profile here. This is the velocity profile. These are the different layers of the water fluids. Okay, here layer 1, here layer 1, layer 2, layer 3, layer 4, like this. Okay, this is the t is equal to 0 seconds, t is equal to t seconds. This is the velocity profile of the flow of waters. Here we have already I told these are the different layers of this layers. Suppose we have to, now I taken as a 2 layers. Here one and another layers. Now I am taking 2 layers. Here the depth of the layer is, the depth of the 2 layer is dy. The depth of the 2 layer is dy. The velocity of the layer is u. Here u plus du. Is it clear? U and u plus du. Here the total depth of the water fluid is y. Here the total depth is y. The depth of the 2 layers. Now I consider 2 layers only. Here layer 1 and layer 2. Here layer velocity of the layer 1 is u. The velocity of the layer 2 is u plus dy. So I am taking the depth of the 2 layer is dy. Okay. Now from this we separate that. Okay, u plus du, here u velocity, here depth is dy. So now I applying the force, now I applying the shear stress apply on this fluid. The particles of the moves in some different directions, moves the some deformation position with different velocities. So from this diagram we show that, from this diagram shows that the applied force applied on the fluid particles, the deforming force is difference. The deforming force is difference to the different layers. Okay, so the applying the force on the water molecules, the water molecules moves to the different position, different velocities with different deformations. So here velocity of velocity, first layer of the velocity is u and second layer of the velocity is u plus du. Is it clear? So from this we can say that the some amount of shear stress applied on the fluid particles, the particles are moved to some different velocities and it exhibits the different deformations Is it clear? So from this relation we can say that the viscosity is directly proportional. The shear stress is directly proportional to the deformation. Different deformation is nothing but shear strain. Therefore shear stress is directly proportional to the shear strain. That is the shear stress is directly proportional to the shear strain. So we can see that tau is directly proportional to the du by dy. Here tau is the shear stress and the du by dy is the rate of change of shear strain. Here du is the change of velocity. Du is the change of velocity. Change of velocity. What is mean by change of velocity? Change of velocity is between the two layers. That is, what is the first layer of the velocity is u. Second layer of the velocity is u plus du minus u. Therefore, is equal to du. Du is the change of velocity. Here, dy is the depth of the two layers. So, here this relation can be written as tau is equal to mu du by dy. Here mu is the proportionality constant. Here mu can be called as viscosity. Viscosity or dynamic viscosity. Dynamic viscosity. This mu is called as the viscosity or dynamic viscosity. This relation is called as the Newton's law of viscosity. What is, how we can say that Newton's law of viscosity? The Newton's law of viscosity is nothing but the rate of change of fluid particles of the shear stress is directly proportional to the rate of change of shear strain. Is it clear? So the term viscosity is nothing but the term viscosity is, what is viscosity? How we can define that? The term viscosity is nothing but resistance offered to the fluid liquids. Resistance offered to the fluid liquids when it comes in contact with another flow of liquids. Okay, so viscosity means resistance offered to the fluid liquids when it comes in contact with the another liquids. That is the viscosity. So the viscosity can be this relation can be written as now we can determine the dynamic viscosity from this relation. So mu is equal to tau du divided by dy. What is mean by that dynamic viscosity or viscosity? The viscosity, the ratio defined as the viscosity defined as the ratio between the shear stress and shearing strain, the rate of change of shearing strain. Okay, once again repeat it. What is mean by that viscosity or dynamic viscosity? Dynamic viscosity is defined as the ratio of shear stress and rate of change of shearing strain. That is the viscosity, dynamic viscosity. So the dynamic units of dynamic viscosity mu is equal to unit of, so tau is the unit of shear stress is equal to Newton by meter squared by the unit of change of viscosity is meter per second divided by the deformation. Deformation is meter, so it is equal to Newton second per meter squared. That is the SI units. SI units. Then CGS units are CGS units are is equal to dyne seconds per centimeter square. 9 seconds by centimeter square. These are the CGS units. So the CGS units can be possessed with the this also can be called as poise. The dynamic viscosity represent as in terms of poise. So 1 poise is equal to dyne by seconds by centimeter square. 1 poise. So this poise value is represents in terms of Newton seconds, can be called as poise. 1 poise is equal to 1 by 10 Newton second by meter square. Okay, the poise represents in terms of Newton second. So poise is equal to 1 by 10 Newton second by meter square. Okay, so in this problem, when we asking the dynamic viscosity in terms of poise, we can use this relation. We can use this relation, then we got the dynamic viscosity. Is it clear? Next, we see that kinematic. Next, we see kinematics viscosity. Kinematics viscosity is nothing but represents the letter is mu. Okay, so the kinematics viscosity is defined as the ratio of dynamic viscosity to the density of fluids. So that the kinematics viscosity mu can be written as nu divided by rho. So the SI unit of kinematic viscosity is SI units of kinematics viscosity is meter squared by seconds. So CGS units are centimeter squared by seconds. Okay. So in this problem, we can calculate the kinematics viscosity in terms of Stokes. So 1 Stokes is equal to centimeter squared by seconds. Okay. Suppose we can determine the kinematics viscosity in terms of meter squared. So it is can be written as 1 Stokes is equal to 10 to the power of minus 4 meter squared by seconds. So in this problem, we can calculate the kinematics viscosity in terms of Stokes. We can use this relation. Okay. Next, we see that Newton's law of viscosity. Already discussed the Newton's law of viscosity. That means tau is equal to mu du by dy. Already we discussed. That is the Newton's law of viscosity. That means tau is equal to the directly proportional. That means the shear stress is directly proportional to the shearing strain. Already we discussed. So from this, those fluids follows follows the which relation, those fluids follows which relation. That means the linear relationship between stress and linear shear strain. Okay, you understand? So these are the Newton's law of relation. Those fluids follows this relation. That means linear relationship between the linear stress and the linear strain. That means linear dynamic strain. So that liquid is called as the Newtonian's liquid. Those liquid does not follow this relation. That means the linear relationship between the linear strain and strain, that is called as the non-Newtonian fluids. Okay, is it clear? Once again, those fluids follows this relation. That means linear relationship between the linear stress and the shearing strain, that is the deformation strain. That fluids is called as the Newtonian's fluids. Those fluids does not follow this relation. That means linear relation between the linear stress and the shearing strain. That fluids does not in the non-Newtonian fluids. Is it clear? So today we learned what is shearing stress, angle of deformation, kinematics viscosity, Newton's law of viscosity, and how to calculate the kinematic viscosities in terms of poise, in terms of CGS units. Okay, is it clear? Thank you.